Assalamu alaikum viewers. Welcome to Nova Educational Academy LARKANA. Dear student, yesterday we discussed about the system of units. We discussed three system of units: CGS, FPS, and then MKS or SI system. So in SI system, we discuss about 7 fundamental quantities. Number 1, length, mass, time, temperature, electric current, luminous intensity of light, and amount of substance. Dear student, in SI system, not only 7 fundamental quantities were given, but their specific units were also given. Along with the specific units, their official symbols were given. So that's why SI system has a particular importance. Length, the unit of length was meter, the symbol is m. Mass, time, temperature, and so on. Well, as we have studied so far, the physical quantities, those quantities which can be measured with the help of an instrument, so these quantities are known as a physical quantities. So here the first physical quantity is a length. Its unit is meter and its symbol is m. So the instrument which are used to measure the length are foot scale, meter scale, measuring tape, vernier caliper, and screw gauge. These 5 instruments are used to measure the length of any object. The next quantity is a mass. The unit of mass is kilogram. The symbol is kg. So the instruments which are used to measure the mass are physical balance, lever balance, and digital balance. These 3 instruments are used to measure the mass of an object. Number 3 is a time. Its unit is second. S or SEC, its symbol. Stopwatch, mechanical stopwatch, and digital stopwatch are instruments which are used to measure the interval of time. Fourth number, temperature. Its unit is Kelvin. And the thermometer, it is an instrument which is used to measure the temperature of any object. Electric current, its unit is ampere. So the instrument that is ammeter, which is used to measure the ampere. Sixth number, luminous intensity, its unit is candela. Now the instrument which is used to measure the luminous intensity of light, that is a photometer. Photometer is an instrument which is used to measure the intensity of light, while amount of substance, it's a number which is expressed in any element. More information about the SI system. ASI system is a modern metric system of measurement. It was established in 1960 by 11th Conference by the World Scientists on Weighs and Measures held in Paris. In that conference, meter was redefined in terms of wavelength of light. The units hertz, lumen, lux, and Tesla were adopted. While the hertz is a unit of frequency, lumen, it's a unit of luminous flux, and the lux, it's a unit of intensity of illumination, and the Tesla is a unit of magnetic flux density. These 4 units were adopted. The new MKSA based metric system were given official symbols as in previous slide. We discussed M, KG, S or SEC, KA, CD. So these are the official symbols of these fundamental units. More important thing which was confirmed in the SI system was the prefixes. The prefix we will discuss in the next topic. Micro, mu, nano, and pico. Micro 10 power minus 6, nano 10 power minus 9, and pico 10 power minus 12, and mega 10 power 6, giga 10 power 9, and tera 10 power 12 were officially confirmed. Dear student, the advantage of SI system of unit is that it makes calculation easier. because smaller and bigger units can be obtained just by a simple division or multiplication by a factor of 10. So that is again the more importance of the SI system. Our next topic is derived units. Derived units are defined in terms of base units and are obtained by multiplying or dividing one or more or maybe a derived quantity with each other. The unit of area, meter square, and the unit of volume, meter cube. Let's see the table. Area, its symbol is A. Its relationship with base quantities, length into length. However, the formula of area is length into width. But however, the relationship of the width is similar with the length. So the unit of length is meter. The unit of, again, the length is a meter, width is a meter, meter into meter, that will be meter square, because whenever two similar quantities are multiplied, their power is added. So 1 plus 1, the result is a 2. So m square is a unit of area. Here we have multiplied two same base quantities. Next is a volume. Its symbol is V capital. Its formula is length, length, length. This is a relationship with base quantities, but however, length, width, and height. So that is the formula of volume. So the unit of length is meter. The unit of, again, width is meter. The unit of height is a meter. So meter, meter, meter. Again, I told you that whenever the similar quantities are multiplied, their power is added. 1, 1, 1. So the power is a 3. So meter cube is a unit of volume. Third is a density. It's denoted by rho. It's a Greek letter. Its formula is mass per unit volume. And volume, length, 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 are length, width, and height. So the unit of mass is kg. The unit of volume is meter cube. When this meter cube just goes on the upside, so the power will remain the negative. So positive will be changed into the negative. So that is a kg, meter power minus 3. That is a unit of density. Fourth, velocity. Its formula is displacement upon time. And displacement, the nature of displacement is simply the length, and again the time is another fundamental quantity. So the unit of displacement is meter and the unit of time is second. So when this second just goes on the upside, its power will be reversed. So meter second power minus 1, or meter upon second, you can write down in very simple way. So meter upon second or meter second power minus 1, that is a unit of velocity. Acceleration, its formula is velocity upon time, rate of change of velocity, and velocity is a derived quantity and time is a fundamental quantity. So the unit of velocity is meter per second, and when it is divided with time, again here is a second. So when second just goes on the upside, minus 1 minus 1, that will be minus 2. So meter second power minus 2, or meter per second square, that is a unit of acceleration. Last, that is a force. Its formula is mass into acceleration. F is equal to ma. The unit of mass is kilogram, which is symbolized as kg, and the unit of acceleration is meter per second square. So kg into meter per second square, it's simply the Newton. So the unit of the SI unit of Newton is, the SI unit of force is simply the Newton. Dear student, as we have learned this SI system, 7 fundamental quantities, and along with the 7 fundamental quantities, 2 other supplementary or units. One is a plane angle. The unit of plane angle is radian, and another supplementary quantity is a solid angle whose unit is steradian. However, in 1995, these supplementary quantities were again added as a derived quantity in the SI system. So that's all about the SI system. Tomorrow we will discuss, inshallah, scientific notation and prefixes. Thank you so much.